Quantum mechanics is weird. There is no denying that. Particles can be in two places at once, objects can be both waves and particles, and measuring something can literally change its state. With all this strangeness, it is easy to see why people say, in quantum physics, anything is possible. Want to teleport across the galaxy? Sure, quantum mechanics says particles can tunnel through barriers, so why not? Want to live in a reality where you win the lottery every time? Quantum theory has many worlds, so maybe there is a universe where that happens. Want to turn invisible, walk through walls, or rewrite reality itself? After all, the quantum world does not follow normal rules, right? Well, not exactly. While quantum mechanics does challenge our classical intuitions, it still follows strict laws. Despite what you may have heard, quantum physics does not say that anything can happen. It says that some things can happen with certain probabilities, and others are simply impossible. Today, in Myths of Physics, we are going to separate the facts from the fiction when it comes to the limits of quantum reality. A big reason people believe anything is possible in quantum mechanics is because quantum systems do not behave in predictable, classical ways. If you roll a ball down a hill, you can predict exactly where it will end up. But if you fire an electron at a barrier with two slits, it does not follow a single path. Instead, it behaves like a wave, creating an interference pattern as if it passed through both slits at the same time. Even crazier, if you observe the electron closely, that interference disappears, and the electron behaves like a single particle again. This seems completely bizarre, and it is. But what it does not mean is that quantum mechanics allows anything to happen. Quantum systems evolve according to precise mathematical rules. The Schrödinger equation, which governs how quantum states evolve, does not allow for unlimited possibilities. It defines strict probabilities for specific outcomes. In other words, quantum mechanics does not give you infinite options. It gives you a set of possible outcomes, each with a probability attached. Some things are extremely likely, others are extremely unlikely, and some are outright impossible. A classic example of quantum weirdness is tunneling. In the classical world, if you throw a ball at a wall, it will bounce back or stop. But in quantum mechanics, there is a small chance that a particle will tunnel through a barrier, appearing on the other side as if the wall did not exist. This is a real effect, and it is even used in technologies like scanning tunneling microscopes and nuclear fusion in stars. But this does not mean that you could walk through a wall. The probability of a human-sized collection of particles tunneling through a solid object is astronomically small, so small that it would take longer than the age of the universe to happen even once. So yes, quantum mechanics allows for strange possibilities, but not in ways that break everyday reality. Quantum tunneling is real, but you are not about to phase through your bedroom door like a ghost. Another quantum myth comes from Schrödinger's cat, the famous thought experiment. The idea is that a cat is placed in a box with a quantum device that has a 50-50 chance of killing it. According to some interpretations of quantum mechanics, before you open the box, the cat is in a superposition of both dead and alive states. This often gets misinterpreted as saying that, somehow, the cat literally exists in two realities at once until an observer looks inside. But in reality, Schrödinger's cat was meant to show how absurd this interpretation is when applied to everyday objects. In modern physics, we understand that quantum effects tend to decohere at larger scales. In other words, superpositions are only stable for very tiny systems, like single particles. The cat, being made of trillions of interacting particles, would almost immediately settle into one definite state, alive or dead, long before you look inside. The idea that anything can happen is also fueled by the many worlds interpretation of quantum mechanics. According to this view, every time a quantum event happens, the universe splits into different branches, each representing a different outcome. Some people take this to mean that everything must exist somewhere, including a universe where you are an astronaut, or a billionaire, or a talking dinosaur. The problem is, many worlds does not say that all logically possible events happen. It only applies to quantum events that actually have possible physical outcomes. Just because you can imagine something does not mean quantum mechanics produces a universe where it happens. Even if many worlds is true, it does not mean you are living in one of an infinite number of alternate versions of yourself. In fact, you may never interact with those other branches in any way. The theory does not let you hop between realities or control what version of yourself exists elsewhere. At the end of the day, quantum mechanics is deeply strange, but it is not a free-for-all where anything goes. It follows precise rules, with strict probabilities and clear limitations. Quantum superposition is not magic. It applies to tiny systems and breaks down in the macroscopic world. Quantum tunneling is real, but only for individual particles, and the odds of macroscopic objects tunneling are effectively zero. The many worlds interpretation does not guarantee that every possibility exists, it only applies to specific quantum outcomes. The idea that anything can happen in quantum mechanics is a misunderstanding of what quantum physics actually says. It does not allow you to defy physics. It does not let you turn invisible, teleport at will, or alter reality just because the quantum world is strange. Quantum mechanics is weird, but it is not chaos. It is just another set of rules, different from the ones we are used to, but rules all the same. Thanks for watching this episode of Myths of Physics. If you have heard other wild claims about quantum mechanics, drop them in the comments and we might cover them in a future episode. And if you enjoyed this video, give it a thumbs up and subscribe for more deep dives into the science that shapes our universe. Until next time, keep asking big questions, and remember, the world is stranger than you think, but not as strange as some people claim.